Okay, this is the PDF book, and this is problem 1410-2E. So let's just take a look at that quickly. So that's this one right here. Let's zoom in on this thing. Okay, so we can see it a little better. And there you go. So you can see everything's in 2 decimal places, but that's okay. But this is a sheet metal part. This is going to be the first one you're going to do. And I'm going to introduce you to sheet metal and some of the things. First thing we're going to do is we're going to do this base down here. And we're just going to do a simple base that's 1 inch by 1.5 inches. Okay. So what you're going to do is you're going to grab, open up SOLIDWORKS, use a USA part or English. And we're going to go into the top plane, and we're going to sketch, and we're going to do a corner rectangle. We're going to go from the origin and down to the left, and then we're going to dimension this. Before, like I said, it's 1.5 long, and then 1. Okay, and then let's go to let's escape out of that. Let's go to an ISO view. And one of the things you have to make sure, right click and make sure that sheet metal is turned on. If it's not, turn it on, because you need this set of menus now. And base flange, you always need the base. Okay. If you look on the drawing, let's go back over, let's drag it in quick. Right here is the 0.06. That's telling you the whole part is that thick. So it's 0.06. K factor is usually set to the thickness of the part, or half of the thickness, so it's 0.5. And we're going 0.06, and we're going in the down direction in this case. And happy check mark, and there it is. Very simple, right? Let's do a quick file save as. I'm just going to throw it on my desktop. I'm going to call it E. Okay, and it's going to say that it already exists because I already did this once. And let's go to a top view, and we're going to sketch on here. We're going to do another corner rectangle. Grab the edge, just drag it out. Okay, and what we're doing here is we're going to be doing this slot feature. And also, let's remember that let's see, it's 1 inch long, but the slot is also 1 inch plus the radius, which is the 0.21. And since it's 0.21, it's also that in width times 2. We're going to grab a center line from it to the center of it. And we know from the drawing that is from the front edge, it's 0.5 for a location. We also know from the drawing that it's 0.21. Okay. And we know the length is 1 plus 0.21. Okay? And that gives us the full slot. And we get out of there, close that, go to our ISO, and we go into our regular features. We're going to do a cut extrude. And in sheet metal, it always defaults, as you guys have seen before, to 0.1. You can go through all, okay? But what I usually like to do is blind and then link it to the thickness. So that way, if your material in your sheet metal changes, that you can actually, it'll change with it and always be the proper. You want to do through all because sometimes it'll mess with more advanced designs. Okay? So again, looking at the drawing, we see that we have a full radius in here, and we also have a 1/2 inch fillet. So we can do those now because they're not going to interfere with anything. So we're going to do 0.5 and select this edge. All right, happy check mark. And then we're going to do fillet again. We're not going to do constant. We're going to do a full round. So this is your first face, second face, and then rotate this a little. Third face, happy check mark. Okay. And we'll do an ISO again. And we're going to save that. Sheet metal is very tricky to fuss with. If you look very closely here, you're going to see that this 1 inch goes to the back corner. Okay, so that means that this back edge is at 1 inch, and facing or pulling forward is going to be to .062. We know that we have to go 0.12 in height. So to do that bend, you're going to select this edge, and you're going to come over here. All right, and it's going to say bend flange, and you're going to see it's going up. If I move my mouse like this, I can go here and say, okay, what I want is 1.12 in height. Okay, but that 1.12 is from the top of the part, so you really have to pay attention to sheet metal. So I'm going to use the 1.12, and I'm going to add the 0.60 thickness. Okay, and then the type of bend. Well, again, we know that from here to over here is 1 inch, and this back edge needs to be there. So if I move these, you can see now that this back edge is in line with that. And the other thing is, the 0.29 represents roughly half the thickness. It's a good rule of thumb to always use half the thickness. Okay, so that original K factor said 0.5. You should set up your radii correctly. If not, if you say the thickness was 0.125, you just want to confirm that. So this, in this case, would be 0.06. All right, and if we confirm that our dimension is correct, we do a happy check mark. Right. Now it has a radius, okay, and it also has a through hole. Okay, so let's look at this again. The location is from the top edge, and in the other direction it is centered about the 0.062. Okay, but this is also 0.062. So there's a couple different ways. I'm going to do the top edge. So I'm going to go to front view, okay, and I'm going to sketch on here, and I'm going to sketch a circle, and we know it's 0.62 in diameter. We know from the top edge, so this one here, to the center is 0.5. And we also know from the center to this edge is 0.62. Okay, it's fully defined, it's black, it's beautiful. And again, we're going to features, extrude cut, make sure it's length to thickness, which it should stay there unless you change it. So that's your through hole. And then we need a fillet. We're just going to do constant size, and the dimension for that we know is 0.62. So we'll change that. We'll select this edge. Looks good. Happy check mark. Okay. Save again. Now we have to do the tricky part. It looks like a sharp line, but in sheet metal it's never sharp unless this thing was paper thin. Okay, and even then, under a microscope, there'd probably be some sort of radius there. We know that if we add the 62 to 125 and this 56 radius, it's going to be 2.43 from that theoretical sharp corner. And we also know it's bent backwards 32 degrees. Okay? So we're going to select this edge. Okay? And we're going to do this. Okay? And if I go up here and then back over here, I can change this to 2.43. Okay? Then I got to change the angle here, which is 32. Okay? And it changed the dimension. I hate when it does that. Okay? So I over here, I type in the 2.43 again. And then if I go into my top, okay, it's still doing it to me. 2.43. So 32 degrees, which looks approximately right. Right. And I'm just going to hit happy check mark. So now it's there. But the problem is, if you look at the drawing, okay, you look in here, this is overlapping incorrectly. So I can go back in, right, and it's even giving you an error, and I can edit that feature. How would you like to change it? Okay, well, you can go like this, okay, You can go past it, which is too much. Okay, but these give you some options. I like this middle one. If I zoom in, it's kind of like being bent just about where it wants. See if we go past it, it's right at the edge. Ah, that's where we really want it. Okay? And we know it's 2.43 long. And hit the happy check mark. Now it's there. But we have to check, is it really the right dimension? So we're going to go into the top view, right, or the top plane, which we are, and we're going to sketch. Right? It's going to ask you where. Right? So we're going to do a top plane again. And what we've got to do is we're going to take this edge and convert it, and this edge and convert it, and convert it. Thank you. All right, and then we're going to trim, do a trim corner, so we're going to go click here and here. Now we have that theoretical sharp corner that they're showing you in the drawing, where the 2.43 goes to. Now if I grab that line and I do a smart dimension, is it the right length? And yes, it is. Okay. So you have to check these things. If you had done a different type of corner, it would mess with this here. Okay, it would give you an improper dimension. So we're good with that. Let's go back to an ISO. Let's just save that quickly. Now we have a 56 radius. Okay, and then we have a slot going on in here. So let's go into features, and let's go in 0.56 for the radii. Right, and let's grab this corner and this corner, and you can see that they meet very nicely. Okay, and that's good. And then we have a slot that is basically the length of the part. Since we really don't have a sharp edge, I would suggest getting your dimensions from this end, even though it's given as a reference, but you still have exact dimensions here. So here we want to do a normal too. Okay, that means it's going to face you, and now you can see this is a bit elliptical on here on the left, and then we're going to sketch. We know that the first circle is going to be right at the center of these radii because of the 56. And we know that it has a size of 0.28, so it's and that's a radius, so it's 0.28 times 2, okay, which is 0.560. I'll draw another circle. See the little dotted line show up, okay, and I can do this, 0.56, right? And then I need a dimension from here to here, and that was given as 1.25, and then to get black is beautiful going on here, I'm going to do a center line, which should clean it up, center to center, okay. So now it's telling that it is in line with the other. Now we're going to pick up the quadrant. Okay. And we're going to pick up the other quadrant. Okay. And we're going to do some trimming. So we're going to do trim closest. And this, and this, and this. Okay. And that gives you this piece. Okay, so we go back into features again, do the extruded cut, length to thickness. Okay, save. Now you're probably wondering at this point, why did we do sheet metal? Sheet metal always starts off flat. And if we go in here and we unsuppress, it turns the whole part flat. And I can send that to a vendor. They can laser cut it, and then we can have it made, and then have them bend it to the correct dimensions. But we still have one more thing to do here. So let's go back to normal 2. Sketch. Okay. We know that slot is centrally located. I'm going to try a corner rectangle. Okay. and I'm going to throw in this here, just to center it up. We know that it comes from the center, so that radius comes in handy again, the 0.56, and we know its width is 0.12. Okay, and then what we can do is just put in some arbitrary dimensions if you want. Call it 2, and then we'll make this whole thing pretty close to 5/8, 625. Let's rotate it. Go into features and let's do an extrude cut. Okay, and that should be everything. So let's save it again. Let's go down into flat pattern, and you got to open it up, and then right click, unsuppress, flattens it, and then go back in and suppress. Okay, and there it is. So that's the first part of it. Next thing is we're going to create a 3-view drawing.
Okay, now what we have to do is we have to move on to the drawing aspect of this. So before, remember, we'll zoom in, and we created this little thing here to make sure that this was the correct dimension. We really don't need that, so I'm just going to right-click that and delete it because it has no effect on anything. I'll save it again quickly. Sheet metal is, as you can see, is a bit tricky to fuss with, but you have to pay attention to what you're doing and you'll be fine. So let's do a new, we'll do a B-size landscape. Okay, B-size is pretty much the industry standard of things, and we're going to want to bring in this. We're not bringing in an ISO, we're going to bring in a front view. Okay, and a top view. Is a right side view necessary? What does it tell us, really? Not much. Okay, so I think I'm going to leave it out. But as always, I always like putting an ISO in. Okay, always want the guys to get an idea of exactly what it is they're doing. I like to shade them, as you know. Okay, and we also need information with our auxiliary view. So we're going to import an auxiliary view off of this edge. Okay. So you see it comes way down here. And if I right click in here, I can go into alignment and break it, and now I can put that somewhere in a better spot. And I'm going to drag these over. Okay. And then happy check mark. Okay, and don't forget you can grab these. I always like to have them point more in the area of exactly what we're focusing on, okay? Because this is where you're going to get the true shape and size of this surface. Okay, here you're going to get elongations or shortenings or foreshortenings, as they're called in the textbook. This is not exactly the length that this is. Let's go into annotation just quick. I measure this, it's 1.06. Right, go into here. Right. It's the real dimension that you got off the drawing, 1.25. Okay, so you have to be careful where you are dimensioning things. So this is part of the print that you would send a sheet metal fabricator. Okay, you're going to put all the dimensions on there and things. Critical dimensions are going to be things like this. It may be that from here to here, the height is very important. Okay, so let's place that. Okay, we need to know that that bend takes place at a certain height, but it's measured from the top, not the bottom. Okay. Another thing that may take place is your angle, but again, where is it bent from? Okay. Sometimes you may actually have to put in a small little line to pick up like a tangent point here in the center, and then go off. Okay. But the other thing that's nice about sheet metal, as we saw before, you can hit a suppress on the fold and it flattens everything. So let's just save this quickly onto, just throw it on a desktop. Okay. Right. Drawing's called E, but we know it's supposed to all be capitals and great stuff like that. Now I want to do insert. I want to do a drawing view model. Okay, I'm going to double click that again. This time I want the flat pattern. So I click over here. Okay. It gives me this. And let's just do a quick refresh. Sometimes the program's a little glitchy. You saw that disappeared. If you just hit the refresh up here, it gives you back your parts. All right. So we have a front, top, auxiliary view, which is A, and we have a flat pattern. Okay. And what you might want to do is grab it and do a projected view off of it. All right. Like I said, 99% of the time you always want 2 dimensions minimum. Okay, but we want to give a thickness. But the other thing is that when you present this drawing to a sheet metal person, you don't need to dimension the hell out of everything. For them to give you a good estimate, you can do the overall dimension, so the thickness, the overall length and width, and that'll help them do an estimate of what this part is going to cost material-wise. The other thing is you can save this whole drawing as a DXF, and then what you can do with that is they can take this drawing, and again, these dimensions are very important, that when they get the DXF, especially of the flat pattern that they're going to put into a laser or a water jet machine, they can make sure that these 2 dimensions are the dimensions that you're looking for. Another thing that's nice on the flat pattern is it gives you, and I'll drag this down a little, it will give you a bend line. Okay, and you gotta pick it up. Okay, there it is. And it's going to tell them the center of the bend point of that part, right? And it's telling you again that in this case you're going at 1.137, you're going up. Okay, and then this here, the 1.516, you're going down at 32 degrees. And the radius, okay, is generally, as a rule of thumb, half of your material thickness, right? So here it's 0.03, here it's 0.06. All sheet metal drawings that you will be turning in for me must have a flat pattern. If they have bend marks, they must be dimensioned. They must have the overall dimension and the thickness. I don't worry about these interior details, the curve, the radii, because all that takes place on your general 3 or 4 view, however many view drawing you need. And that sums it up. The rest of this, you go through and you dimension as usual. Make sure all the dimensions that are there, you have size and location of all features.
The circle is now complete. When I left you, I was but the learner. Now I am the master.